Welcome everybody to our session, our clustering deep dive session, part 2 actually, because Duncan and Frank did the first part just yesterday, covering HA and DRS. Today we are going to talk about quality control on the networking side. So we will be talking about network I/O control, and we will be talking about network DRS, network aware DRS. So I want to start off with a quick introduction. Sahan, if you will.
Yeah. Hello, good afternoon everybody. My name is Sahan Gamage and I'm an engineer in the DRS team for the last 5 years or so. I've been working on integrating I/O metrics into DRS algorithms and some other stuff as well. I'm originally from Sri Lanka, but now I'm based on Palo Alto. So, after the session, if you have any questions regarding network DRS or in DRS in general, I'd be happy to answer, and I'll be doing the network aware DRS part. Yeah, thank you.
Thanks, man. So, I'm Niels Hagoort. This slide actually states that I still have my own company, which is the case for the next 2 weeks because I will be joining VMware in a tech marketing role. So, the slide is not entirely accurate. Let's get started. Disclaimer. I will cover the network I/O control part. Sahan will take over for the DRS part. So, let's start going with NIOC, short for network I/O control. I want to take you and begin with the basics of network I/O control, right? So when you create a distributed vSwitch in your virtual data center, network I/O control, it's actually flagged to enable by default, and it's only available on a distributed vSwitch. Now what we have by default is system network traffic types, and those are default, right? There's not anything that we can configure or add on that part. And we have the user-defined network resource pools. So when we see a distributed vSwitch that is enabled for network I/O control, you will see on the right-hand side, the right highlight, that it's actually enabled the version, which nowadays in a current vSphere install base, you will have version 3. We used to have version 2 as well. A number of physical network adapters in that specific cluster or that specific distributed vSwitch. We'll see some numbers on the available bandwidth. We'll come back to that later on. And the default traffic types that are configured. So we have management traffic, we have IP storage, NFS or iSCSI traffic. We have vMotion, vSAN, almost everything, right? And the interesting thing about this screenshot is when you look at the virtual machine traffic somewhere in the middle, you will actually see that it's set to a share type of high with a share value of 100. And that kind of shows you that NIOC will always prioritize VM traffic, your application traffic, over all other traffic types, right? The application availability and bandwidth comes first. So we have several constructs to configure for each traffic type. So we are talking about shares, we have limits, and we have reservations. The same goes for the compute DRS side, for instance, right? So this test is just to show you how shares actually work and how those are dynamically calculated. And the most important thing about network I/O control is to understand that it only kicks in when a physical NIC is saturated. So if bandwidth is consumed up to the fullest on a specific physical NIC, that's when network I/O control comes in. So in this specific example, we have 10 gig uplinks, and we kept the shares for those specific traffic types to a default. So we have management, NFS, vMotion, and VM traffic with the default 100% value. So if we look at how that gets divided, and obviously this is a theoretic example, right? We will see that VM traffic, because it's a higher share number, will actually get 40% of the slice. And that translates using this formula to 4 gig of network bandwidth entitled to VM data. And 2 gigs for NFS, vMotion, and management. Now, what if 2 of those are not consuming network I/O? then it will automatically and dynamically recalculate. So it's important to understand that the network I/O scheduler is always running and always checking saturation, demand, and doing resource management to actually come up with this formula and divide the available bandwidth over the traffic types. Key takeaway is it's dynamic, right? So let's assume, oh, there we go. So what if we have limits as well? So limits, by default, it's not per se the best practice to enforce limits. That goes for either compute or network or storage. Because the thing is, a network traffic type is never able to go beyond the configured value for the limit, right? So it's kind of sensitive to human error. But still, there are some use cases, perhaps vSphere data protection backup traffic that might be running during the day, I don't know, or during the night. And you do not want that to consume the whole available bandwidth, right? So we are limiting this traffic to 3 gigs in this example. Now the thing with limits is, and that's also something that's easily forgotten, is that when you look at the diagram, when you have a ESXi host with 2 uplink connected to the distributed vSwitch, and the VMK interface in the VDP network traffic type is limited to 3 gigs, that's actually enforced per uplink. So when you configure 3 gigs limit, that is a total, when using 2 uplinks, to a 6 gig limit for that specific ESXi host. So that's something that to keep in mind. And limits are fairly easy to test, right? So we had this network I/O test set up, and we just let it keep on running and had a look at how it's actually enforced, right? So we have the 3 gigabit limit test, and you'll actually see in this screenshot, which is ESX stop, the network view, you will actually see the 2 uplinks being enforced to a almost 3 gig limit. And while the test was still going on, we changed that value to a value of 2, for example. And you will actually see that within a few seconds, the network I/O scheduler will actually enforce that new limit as well. So it's dynamic and it's changeable, so it's not set in stone if you configure a limit. So the thing with network I/O control, and this comes sort of into play when you talk about limits, is that it's all about perspective. And it's good to know that network I/O control is only enforced on ingress traffic. And that's from a distributed vSwitch perspective. So when a VM is actually sending out transmitting network packets to the distributed vSwitch, that's considered ingress traffic. The same goes for an uplink, which is going into the distributed vSwitch ingress traffic. But from the distributed vSwitch to a VM, or to a VM kernel interface, that's considered egress. And network I/O control nowadays is not able to enforce on egress traffic. So we could have this corner case scenario, and let me stress this is just an example, right? But let's assume we have 3 hosts in a vMotion network, and 2 of those hosts are actually source hosts. We have 1 destination host, and we have a limit enforced for vMotion traffic of 5 gig. But when we are evacuating VMs from the source host to the destination host, they will probably consume up to 5 gigs, making it a total of 10, with a possible saturation on ESX number 3. And NIOC can't do anything with that, right? Because, sorry, we'll take questions on the end. Because the destination host, that's considered egress traffic. So what we can do on that part is actually introduce another quality control mechanism within vSphere. And that is called traffic shaping. So in this specific scenario, we could opt to go for a configuration with egress traffic shaping. So we went ahead and configured an average bandwidth size with 7 gigs. So for egress traffic shaping, and that is used by the by the destination host. Oh, let me check. There we go. Sorry. So you'll see now that the receiving host, the destination host, is actually, because we enforced traffic shaping, egress traffic shaping, it's cut down at 7 gigs. And the way network protocols work, the source host will actually be tuned down to around 3.5 gigs, right? So again, it's a corner case, but it is good for you to understand how network I/O control works, that it only works on Ingress, and that we can mitigate risks with egress traffic shaping if that is required. So we talked about shares, we talked about limits. We will now go ahead and talk about reservations a bit. And reservation is kind of like limits, right? It's not always a good idea to enforce reservations, but hey, you might have a use case for it, right? That specific customer, that specific tenant, that specific application. And from an SLA perspective, you are required to ensure a minimal amount of bandwidth. The thing with reservations is once you have a reservation in place, that bandwidth is the I/O scheduler, network I/O scheduler, will consider that bandwidth to be consumed. It's gone. It's not redistributed to other VMs or whatever. So whatever you configure as a reservation, that bandwidth is gone. We have a safety net at 75%. So that's for obvious reasons, right? Because still it's sensitive to human error. So if you have a 10 gig NIC in the diagram as well, in the example, it will allow you to reserve up to 7.5 gigs of bandwidth. And the same goes as with limits. It's enforced per uplink. So if we have, for instance, vSAN traffic, and we want to have a 2 gig reservation for that, it can obviously burst beyond the reservation, right? It's not a limit. But we want to make sure that we have 2 gigs available per ESXi host for vSAN. It will be enforced per uplink, making it a total, in this case, of 4 gigs. Now, if we want to have a more fine-grained methodology of having reservations, we can do that as well. So, looking at network resource pools, those will allow you to actually have distributed port groups and VMs connected to it, and reserve specific bandwidth for those specific port groups and VMs, right? And in order to do so, we need to go back to the virtual machine traffic type, because that's the upper layer beyond just after the distributed vSwitch uplinks. So whatever bandwidth we reserve on that part, we get to divide over network resource pools. So when you look at that from a UI perspective, and I'm not sure if this is readable for everybody in the room, but we have here the virtual machine traffic, right? Remember, we need to have a reservation on that part. Otherwise, we cannot even create resource pools and reserve bandwidth in those resource pools. So in this specific case, we only opted to go for a 2 gig reservation for VM traffic. And once we did that, we'll actually see in the screen on the right and the upper highlight that we have 12 gig reserved, 12 gig bandwidth reserved for this specific traffic type. And that is because in this scenario we have 3 hosts. Each host has 2 uplinks, making it a 6 uplinks total. And we enforced a 2 gig reservation. 2 times 6 is 12. So for the whole cluster, we have 12 gigs of configured bandwidth reservation. So now we have that reservation in place. We are actually able, and that's the lower highlight on the right side, we are actually able to create network resource pools. And we tested some with a high value workload resource pool and a low value workload resource pool. Whatever goes. And now, once we have these network resource pools in place, when we create a distributed port group, because remember it's still only available on distributed vSwitches. We can now select a network resource pool. So we can immediately have a new distributed port group, in this case application X, because this application needs its own network for whatever reason. We can now connect that to that resource pool and automatically have that bandwidth reservation in place for all VMs connected to that specific port group. Now if you open that in the UI, you will actually be able to, per network resource pool, to see what port groups are connected to it, because you can connect multiple port groups to a single network resource pool, if you will. And the same goes for the VMs. And this is an interesting point as well, because you can have reservations and all the constructs, the shares on multiple levels, right? So we now talked about network resource pools with port groups connected to it, but you can even get a more fine-grained reservation model or share model on a per VM basis. And that's on one hand, that's a good thing, freedom of choice, but it does introduce a operational overhead, if you will. I mentioned several times that it's sort of, if you're not automating this part, it's sort of sensitive to human error. So it does require you to really think about what I'm doing when it comes especially to limits and reservations. So keep that in mind, because if you misconfigure something like that, it's perfectly possible that vSphere will prevent a power on because the demand cannot be met on that specific host. So to bring that all together, we will see that Network I/O Control, NIOC, is actually there to help you in time of great need, and when you have bursts and loads on a short-term basis. And the goal of network-aware DRS has everything to do with fixing long-term prolonged imbalances. So that is far more intelligent on where to put specific workloads on and everything that comes with it. But that's my buddy Sahan, who will take you through the trenches of network DRS.
Okay, thanks, Niels. So let's now look at what network-aware DRS is and how it can help DRS to make better placement decisions. I think one thing I wanted to clarify is a lot of these controls that Niels talked about in the previous set of slides is implemented at the host side. So you have network resource pools, shares, reservations, and limits that are all working at the host side. But so if you look at the equivalence things, so, we have CPU resource pools, memory resource pools, and then you have an equivalent at the cluster level. But unfortunately, we don't have such a thing for network NIOC settings, right? Network settings. People will say, oh, if the host supports it, why are you guys not doing it, right? Well, it's not that easy. I'll show you why it's not that easy. Plus, at the same time, I'm kind of going to discuss what are the things we considered. And if you look at the name itself, it's not network DRS, it's network aware DRS. So you get the slightest idea here. At the same time, we are not doing the fully thing of load balancing and every fancy things that DRS does for CPU and memory. So we are trying to be network aware while we are doing things. And one more thing I kind of want to kind of do a disclaimer before we start. Niels is more of a practitioner, so you saw a lot of numbers, a lot of examples. I'm more of like an engineer working on the code. So you'll see a lot of flowcharts and things like that compared to numbers. I wanted to give you an idea how things work inside, what are the decisions we make. Some people like it, some people hate it. I don't know. So let's see. Let's move on. All right. So what is NIOC is good for? If you have a good idea of network requirements of your VMs, for example, you have this, telco VMs or, some VMs that have RDP traffic or, some database traffic, you kind of have a decent idea how much traffic these VMs require. And these are like, if you compare thousands of hundreds of thousands VMs that are in your environment, maybe this is a few or very limited number, and there are others like hundreds of thousands of VMs that you have no idea of, or you have no interest of tracking and figuring out how much network bandwidth they require. But the problem is, you want to make sure that these VMs get enough adequate network. So, but the problem is if you go and set some unrealistic reservations, this is not going to help in the cluster, because as soon as you set a reservation in the cluster of any of the settings, that kind of blocks DRS making moves, because now you have these hard limits that you can manipulate. So setting reservations is always kind of discouraged for many things unless you know exactly what you're doing. But the problem here is that if you don't set any of these things before we network aware DRS can do some bad things from network point of view. For example, we have seen situations, and we got to hear through bugs and SRs that there are situations we overloaded one of the hosts from network perspective, because DRS only cared about network, CPU and memory. So if DRS thinks, oh, this host is good from memory and CPU perspective, it didn't know about network utilization of the host. So it kept on loading to one host. So these bad things couldn't happen. So how do we make sure that we at least care about networking and look at the networking metrics? So that's the solution we came up, network aware DRS. So let's go a little bit deeper and discuss what are the goals when we did the network aware DRS. But before that, let's do like maybe a 30-second primer of the DRS. What DRS is doing. So the primary goal of the DRS is to make VMs happy. Well, happy is a very vague term, right? I mean, how do you even make a person happy? You have no clue about what they need. So, but in our definition, what makes VM happy? Giving its resources when it requires, right? In early days when we did DRS, we didn't have a proper way. If you attended the session yesterday about what's new in vSphere 6.7, we claimed that we figured out a decent way of how to make a VM happy. Well, not so sure about it, but we are trying to. But in early days, what we thought was, okay, if you make the cluster balanced, cluster utilization balanced, in turn we are making VMs happy, because in a balanced cluster, all the VMs should be getting enough resources. So that's what the famous cluster balance, this bubble is about, right? Let me ask, how many of you has seen this bubble? Good. Does anybody know what this bubble means? I know going to the left or something is, it's bad.
It's being with the standard deviation of the...
Yes, so it's the standard deviation, good, right. One little known fact, does the bubble go to the left ever? Probably not, because standard deviation is always positive. If you are sitting at 0 at the middle, maybe it would not go to the left. So that's the famous bubble, but the goal is for DRS is to make the cluster balanced, right? So that's the whole idea. We've been feeding people, say if you look at the cluster, if it's not balanced, maybe something is going wrong, and this idea we have somehow implanted in people's mind. So that's good. And we looked at CPU and memory, right? So during initial placement, what we did was we looked at the entire cluster and said, if you place this VM in this particular host, the cluster will be balanced after the power on. So let me take that decision. So that's how we arrived on that decision. And once you power on a VM, while from time to time your load can go spike and things like that, and load may increase or decrease. So from time to time, DRS ran this load balancing algorithm, and then figured out if one host is overutilized or some of the VMs are not getting their demand, meaning VMs are unhappy, we kind of made vMotions. And then we considered rules as well. Sometimes HA might restart the VMs on a host that is not violating some of the rules. So we had to fix that from time to time as well. So these are the things that old load balancing did. Now the problem is, how do we introduce the networking into this picture, right? So we want to do this. But the problem is, defining the balance of networking is pretty challenging, Because networking, unlike CPU and memory, is not a resource that is in one host, right? CPU is in one host, memory is in one host. So you ask the question, what is the CPU utilization of this host? What is the memory utilization of this host? Easy to answer questions. But then you ask, how do we satisfy the networking demand of this VM running on this host? Because the networking involves source host, PNIC, and some wire going through, some of the switches and routers and things like that, and then going to the destination host. So if you wanted to define, balance in networking, where is the balance you're talking about? Are we talking about the balance in the core switches? Are we talking about the balance in the network utilization of the host? This is a tough thing. And we are already having a hard time defining the balance of CPU and memory, because it's like formula we kind of combine to get that bubble, and defining balance of two things is already hard. Imagine you incorporate an unknown thing into the into this picture as well. So it's hard problem. So that's why we are not doing network DRS at this moment. Maybe in the future we might do it. So what we're doing is basically consider the networking as a second-class citizen. That means we try to make the balance of CPU and memory as such, like before. But when we do placement decisions, we consider the destination host and source host network utilization. Say, can we make better decisions? Can we improve the decision by ourselves? So this is the goal of the network-aware DRS. All right. So to summarize all the things I've been talking about. I told you that unaware of the network utilization in the cluster can create some bad situations in the cluster by doing bad placements by DRS, and then we need to introduce network balance slowly into the picture. We don't want to violate the picture that people had in their mind. This is the balance cluster. How do we define the balance cluster? These guys have written books about the balance, talking about that balance. So we don't want to deprecate these books and all these things and go and in one release. We don't want to do that. So we are trying to introduce network metrics into the DRS picture slowly. So 6.5 and 6.7, we had 2 releases in the past. So that's what we are trying to do. And to make things more clear, let's not do bad things from network point of view. Let's try to do CPU and memory more advanced way, do better by making the balance as a goal, but let's not do bad things from network point of view. So what we did for initial placement. So I'll be mostly focusing on 2 workflows. I mean, we have maintenance mode and other things, but for this discussion, I'm going to talk about only about power on, what happens during power on, and what happens during load balance. Rest of the things, I think there are white papers out there talking about it, but we will be mostly talking about this because this is the most important places to discuss about what happens from network point of view. So during initial placement, we will first get a list of hosts that are best from the balance perspective, and then we'll look at the best host out of that from network point of view. I'll discuss details in a later in a flowchart, all boring flowchart, but this is the high level idea. So you basically make sure that your cluster is balanced from CPU and memory perspective, and then out of that you optimize that using the network metric. And during load balancing, we are basically trying to do what is called avoiding doing bad things and trying to help ease the situation. For an example, if you're thinking of a vMotion, if DRS is thinking of a vMotion that will move a VM from host and then it's going to a network saturated host, we think this is a bad move because it's going to create bad situation in the destination host. So we try to avoid that. And then if you have an already saturated or near saturating host, we try to vMotion out some of the VMs from that situation, so we can kind of remediate that situation. All right, so what are the controls we have? The good or bad thing is a lot of this logic is inbuilt, so network DRS is enabled by default when you use 6.5 or 6.7, and a lot of numbers are baked into the algorithm. But sometimes, depending on some of the environments, in corner cases, you might not like the decisions made by network DRS. So there is an advanced, the same old way we let people do little funky things in DRS, we have an advanced option. You can disable network DRS by setting the value to 0. So that's the first thing. The second thing is, I talked a lot about saturation. So how do you define the saturation, right? So we right now look at the total network capacity, all the capacity of the PNX, and then all the network usage in the host. And this is how do we define the network saturation, use capacity and usage, and there's a threshold. By default, we think 80% is the right thing. That is what we have heard from people. And that's what we consider by default, 80%. If you go beyond 80% network utilization, bad things going to happen. Packet drops will start happening. But some environments are different. If you think I have a super fast, super reliable network, then some people think, oh, 90% may be my value. Or if you think, oh, maybe I want to be a little bit conservative and save, some bandwidth for other stuff, then you can do 70%. You can change the value. So that's the idea. We give that advanced option. The name is a little long. You can copy paste. Nobody reads and try to remember these things. Just copy paste from somewhere. But this is the advanced option. So you can set the threshold for that. The final thing is actually monitoring tab. In the past we had the CPU utilization and memory utilization tab. So you can reason about what are the moves that DRS did. So all the things are like recommendations, false, and history kind of says these are the things happen in the cluster, and then the utilization kind of helps you to get a picture why these things happen in the cluster, right? So that is the idea of this having all these tabs. So we added network utilization because now network impacts to the DRS decisions. So we should show the network utilization as well, so you can kind of figure out, oh, network might have impacted the this decision. All right, let's go and see what the implementation or architecture looks like. This is the old DRS. So I'm going a little bit faster because you might already know this stuff. So we kind of use CPU and memory usage statistics, and then DRS ran and gave some vMotion and power on decisions. So this is the old way of DRS worked. So how does network DRS works? We add, I don't know the bold thing is there, but we have CPU, memory, and networking. For networking, we actually monitor VM's VNIC usage, all the VNIC usage, network usage, RX and TX both, as well as PNIC usages, RX and TX both again. And then along with the other CPU and memory, we monitor these things every 1 minute interval. So these metrics are sent to the vCenter at every 1 minute interval from each host. And then we run the same the new network DRS algorithm, and the output is the same. vMotions and power on decisions. All right, so let's look at how power on works, a detailed look at how power on works. Okay? So I want to tell you that I've separated the power on work for vSphere 6.5 and 6.7. Again, if you kind of have a chance to review the yesterday's session about what's new in vSphere 6.7 on DRS perspective, we kind of highlighted that we have a new algorithm that works for the power on only. I mean, we have a new algorithm for the entire load balancing, but it's not out yet. Sometime it will be out as well. In VMC on AWS, we have all the new algorithm working on for power on as well as load balancing. So this kind of where we say load balancing is not the most important thing, but giving the VMs its resource demand is the most important thing. So where we look at the ready times and all this stuff. Please have a look at the yesterday's session if you want to get that details. But the idea is 6.5 power on and 6.7 power on are quite different. One of the good things is 6.7 power on is at least 2x faster than 6.5. So that's a good thing. So VM power on call comes into DRS. And what we do at that point, this is a review of DRS in the first place. What we do is basically we construct a view of the cluster. We want to see, what is going on in the cluster. We look at the CPU and memory configuration of each host and VM. So we put it into a memory place. We gather that, as well as the metrics I showed about, the last metrics we have seen. We combine these things into what is called a snapshot of the cluster. So DRS basically operates on this snapshot of the cluster and looks at saying, how is the cluster balance is going? If I place this VM on this particular host, is the balance is going to be fine or it's going to be worse? Right? So that way DRS iterates through each host to figure out what is the best host we should place this new VM. So then it basically outputs a set of hosts. if you have used in DRS in manual mode in the past, you might see, star rating and all the list of things. So that is the list I'm talking about here. But the thing is, if you look at a decent sized cluster, there will be always more than one host that has, first class rating or, highest star rating. So what we do is we figure out this top candidate host and run network DRS algorithm, which basically looks at all the three metrics. It's a new vector function that we use here. But the idea is basically that function combines all the three metrics out of these hosts. CPU, memory, and networking, and then we figure out what is the best host on all three metrics. The good thing is, we are already looking at the best host from the old DRS algorithm point of view. That means we are not going to violate the cluster balance. As well as we are looking at the network metrics, so network point of view, we are good as well. So that's the 6.5 workflow. But if you go to 6.7, we said, you know what, 2 steps are too time consuming. Let's try to combine them into 1 step. So we have this new formula defining how the VM can be happy. What is its resource demands and what is its efficiency, all that new things. But based on that, we kind of define a new formula how to make a VM happy. So the integrated formula will consider all the 3 metrics. But one thing I need to say is that network is still a second-class citizen because it has a lesser weight in this formula as well. CPU and memory are still the primary concern. That is what we heard from a lot of all of you when we had TAM sessions in the past. Consider CPU and memory first and networking second. So we honor that request. So so we get a list of rank hosts. So let's look at how load balancing works. So load balancing is, there's a load balancing thread. If you don't change the cluster settings, we run at every 5 minutes. There's a thread that wakes up, and every 5 minutes it constructs the cluster snapshot as I talked before, which will basically look at the CPU memory configurations and then the current metrics I have talked about before. So then, so then it will run this load balancing algorithm. Basically, it looks at the snapshot and figure out if I make this VM move from one host to another, how's the balance going to be? So this guy, actually, the core DRS part algorithm proposes a lot of vMotions, because if there's even a slightly improvement in the level of the balance, this guy says, let's take that vMotion. So but if you look at your cluster, there's not many vMotions happening for a given run, maybe 1 or 2, 3. If the cluster is super busy, maybe 5. So what prevents taking 1,000 vMotions at a time? We have something called cost benefit analysis. Basically, this guy is the one saying, no, you can't do that because it's too costly. So what's the benefit? Basically, you improve the balance of the cluster. You're giving more resources to a VM. But what is the cost? You have to vMotion a VM. vMotioning a VM disrupts the cluster, disrupts the VM's operation. So all that we consider into the cost benefit analysis. So CB filters basically figures out what's going on in the cluster and how much disruption it can do, and either says yes, go ahead, or no, you're no good. So what we did is basically we added 2 priority functions to using network to this one. The first one is basically look at the source host of the proposed vMotion. So when the algorithm basically proposes a vMotion to the cost benefit filter, this filter goes and looks at what is the network utilization of the source host. So if the source host is basically saturated, network saturated, and the VM is using some of that networking, we say, oh, moving out this VM might help to relieve the saturation, right? So we basically say we bump up the priority of that vMotion so it won't get rejected by the later cost benefit filters. So that's the first thing we do. The second thing we do is basically look at the destination host. If the destination host is either saturated or near saturation, we say if we move a network utilizing VM to that destination host, that's going to make a situation bad. So let's not do that. So it basically flat out rejects the proposal. So those are the 2 things we added from the network's perspective. So now you can understand why I said don't do bad placements kind of approach. One little thing I wanted to highlight, this is like a very little detailed fact. So if there are 2 VMs communicating on the same host and they're not separated by either subnets or VLANs, I think, how many people think it's a better thing, host internal networking? 2 VMs, like, internal traffic. Anybody think that's a better thing or a bad thing? Yes, it's better because for a couple of reasons, actually. The first thing is when you have such a situation, internal networking basically bypasses all the PNIC and host networking stack and just do a short memory copy. So that means you can enjoy better bandwidth. That's the first thing. The second thing is it's not going to utilize the networking stack. That means you're saving some CPU cycles. That means that can be used for other VMs or other things in the host, right? So it's basically two-pronged, and it's very, very good in my view, and most of the time. But the problem is if DRS is not aware of this situation, right? So let's say you're trying to move one of the VMs, say the middle VM on that left side. The problem is if the VM is moved to some other host, that internal traffic going to be converted into external traffic, right? So what will happen? Basically, it will start hitting the PNIC. It will start utilizing the host networking stack, and maybe if the PNIC was near saturation, it will go into saturation, right? So that's a bad move. So instead of looking, so now, if you just monitor the VNIX traffic, that's not going to help. So that in our situation, actually, I kind of skipped that thing because of the complexity. We are not just monitoring VNIX traffic, we are monitoring VNIX internal traffic, VNIX external traffic. So those statistics will be considered in the DRS algorithm. So we have some complex calculations to see if how much of this traffic will be going to be contributed to the PNIC once you make the move. So these are the things we considered during the DRS load balancing algorithm. So that's all I have, but I wanted to highlight some of the things we have been doing in the past and some of the future slides. So in the vSphere 6.0, we had NEOC, but only on the host side. So what we did was we incorporate the NEOC reservations to DRS algorithm. So basically, we do admission control. If you have set a reservation, we don't allow the reservation violations happening. So that's good. So that means you can protect your, important network perspective, important VMs from, other disruptions. So that's good. But then on 6.5, we added support for the rest of the VMs. So, other VMs can be taken care as well from the network perspective. With 6.7, so that's the idea. You want to push the networking components as close to the core of the algorithm. So that's what we did, basically one function, more integrated function. But in the future, we are trying to define some of the things like, we are trying to look at the communicating VMs, can we move them closer together? Or, should we consider things like jitter, latency sensitive VMs, or VMs that have like, elephant versus mice flows. But, we need kind of your input on that thing. We would definitely contact me or our PM or even Niels, if you have any input regarding that, if you have like burning requirement, we would definitely like to address. So with that, I'm going to hand to Niels. Oh, yes. I already did. So, yeah, sorry.
Thanks. So, about this slide, everything that we just talked about and Frank and Duncan talked about yesterday is in our book, which isn't available on Amazon, but Rubrik gave them away. So they might have some left as well. So drop by the Rubrik booth if you are still looking for a book. And I think we do have some time incorporated for questions, if there are any. And so, sorry to interrupt you. If you have a question, somebody will come up with a microphone, actually. Where was the question, sorry?
Mics are on their way around.
Yeah, the microphone is on its way. We are here in the middle. Just throw it over.
Throw it.
Yeah, exactly. Yeah, they used to be.
So, would it still apply when you use predictive DRS? Does that make a decision based on network and network utilization?
Unfortunately, there is no predictions from the network as of now, but we are trying to do that as well.
So, could you, for example, expanded to use Network Insight in the same way as VROPs today to make those decisions based on traffic flows and network information from that.
Right. So at the moment, VROP sends us these predictions to us. If they, as of now, we don't have inside DRS algorithms for these predictive stats, room for predictive stats for network DRS. But if VROP is willing to send these stats, we can definitely incorporate, because this is another stat for us.
Do we have another question as well? Yeah, well, pick one. Sorry.
Are there any plans to integrate this with HA admission control?
HA admission control already looks at NEOC reservations, but not so admission control is more about reservations, right? Do you have anything else? Like, we don't look at utilization.
No, admission control with HA, is looking at CPU and memory reservations.
We do have plans, yes, we do have plans to HA and integrate better placement decisions.
Okay.
Yeah.
The other question I had was, are there any plans to update the UI? Because at the moment it's network I/O control, all of that stuff is in like 3 or 4 different places. I thought it would be nice to have it in the navigation pane, like memory and CPU resource pools. And then you could actually see which port group is associated with them, which virtual machines are associated with them, and then it would all be very much more visible and easier. You wouldn't be drawing your own pictures of how it's all configured.
That's good feedback. Yes.
Thank you.
We have another question in the front there, I believe.
Thank you. So you always talked about having 2 uplinks and all the traffic flowing through it. So we do have 6 uplinks, 2 for management, 2 for storage, and 2 for VMs.
Yeah.
So would I be able still to use network I/O control or is it even needed for such a separate interfaces?
Yeah, well, the main thing about network I/O control is that it only kicks in when a NIC is saturated, right? So when you divide over multiple NICs, well, the chance you will saturate a NIC will be, well, close to nothing, perhaps. So yeah, but it doesn't harm either, right? So that's why it's enabled by default when you create a distributed vSwitch. So that's one thing. You have all the NICs divided over multiple distributed vSwitches, not standard vSwitches. So yeah, I would say always keep NEOC enabled. Doesn't hurt to have it enabled. So yeah.
Thank you.
Thank you. Do we have another question as well? Here in the front, they were waiting for quite a bit. Sorry.
Yeah, in fact, I had a question about predictive DRS, but also was thinking about another question. Do you have any plans from a network-aware DRS perspective just to check the environments? For instance, if you have several VMs which communicate in HUD with each other, so maybe we won't lose from memory and CPU perspective, but if we will migrate to the single host kind of host affinity rule, but automatic and not related to host affinity rules.
Yeah, that's one of the features I think I had in the future end of the things. We kind of did a prototype on that one. We had good results, but we are looking at more input from the clients and customers, because if it's from engineering perspective, doing a prototype is one thing and proving a concept is one thing, but then there should be a strong demand from the customer side to fund it and go through. But yeah, we are basically looking at it, and we have seen, instead of so we have to basically define a goodness value. If you co-locate them and if you're communicating, we have to say, oh, CPU saving, more networking bandwidth saved. So things like that, we had a model, basically we integrated that goodness model, the distance and the communication bandwidth. So you can bring them together, then the distance shrinks and your communication increases. So we incorporated that and had a prototype working. So it will take, in sooner we are trying to do that.
It's on the agenda. Right?
It's on the agenda, yes. That's the standard.
Exactly.
Thank you. And are you looking at MSX here, especially in this case? I guess it would be easier to manage from VXLAN perspective. If VM's connected to VXLAN, you have much more control than without sidewall.
Actually, the prototype we did was based on NSX.
Okay, actually I have a question about goodness settings. Right now the default culture of the DRS when it's find the cluster imbalance is to find the biggest VM and just throwing it to the best possible host, yeah? And in certain situations, this is not good because actually the biggest VMs actually are the most production ones, the most important ones. Right now there is this setting about latency sensitivity that actually like tones down a bit the situation. From what I read, when I set up VM from the latency sensitivity high, it's actually it isn't as vMotioned as much, yeah?
Yes.
But actually, I don't want to set all my most important production machines to the high, to the latency sensitivity high, because it has other considerations. I need to set up reservations to the maximum, all the jazz, yeah? So the question is there any available advanced DRS settings that enable us to like change these goodness settings, like maybe ease the cost of the vMotion operation to consider vMotion smaller machines more than throwing big VMs?
Yeah, I think that's one of the problems we have seen with the the balance model, because if you move a larger guy, that'll have a major increase in the balance. So that has, but that was kind of unintended behavior, because we were not thinking, I think one of the original ideas is we should not move large VMs, because that introduces a bigger disruption, right? So there's two things. The balance improves much if you move a larger guy, but you have basically the disruption is higher as well. So kind of it comes to the cost benefit filter saying either you should take it or not, and that difference, right? But the thing is, with the new goodness model, actually we have baked in saying less prioritization for moving large VMs.
Yeah, because actually one of the things it was in the DRS that you are locked on the active memory usage that actually led sometimes to the oversaturation of the host when we throw at big VMs.
Right, and if you
especially during the night, and
yeah. So then there's another thing. We have something called compute policy coming up in the next few releases. It's already available on VMC on AWS. So if you don't want to trust the algorithm, you can basically tag a VM saying, do not vMotion this VM. We have through tags. So you can set up a policy saying with the tag name X and Y, XYZ, VMs with this tag do not vMotion this, and you can keep on tagging those VMs all the time. So that is not as harsh as setting latency sensitivity, because latency sensitivity has some other implication as well.
Yep, that's true. Thank you.
But the problem is, I'm from DRS, and I kind of said, if you have a large number of VMs to do so, setting affinity rules is not a good thing that many. Like when you go beyond 100, 200 affinity rules, it's hard to track down.
Especially for the DRS, because DRS need to consider this as well. So every 5 minutes it needs to read all the rules. Yeah.
Right.
Right. For everybody that stuck around, I do still have some clustering deep dive shirts available. The staff told me I cannot give them away in the room because rules. So what I will do, I will actually take them with me just outside. So everybody who wants to have one, I think I have like 20, 30 left. So I do not want people to fight over it, but I will take them with me. And thank you for being here.